Question 9. Noah is attempting to work out the base of different right-angled triangles. It's not drawn accurately, so don't get your rulers out at this stage. It's about the mathematics behind calculating the length of sides of triangles, which should trigger your mind to say Pythagoras' theorem, where we square each of the two short sides and add it together to give us the longer side, the hypotenuse. Here is his method with the working for y equals 10 and x equals 6. We work out what y squared is, which is 10, so 10 times 10 is 100. Work out the value of x squared, so 6 squared is 36. Find the difference, because we already know the hypotenuse, so we take away one side squared to find the other. So that gives us 64. The base, therefore, would be 64 square rooted to give us 8. So which of these statements is true? The method will always give an answer which is a whole number. Well, this one gave a whole number. The method will sometimes give an answer which is a whole number. That's one we're going to have to try and prove. And the method will never give an answer which is the whole number. We have to show some working to support our answer. It's a 3-mark question, so don't just get tempted to tick a box and leave it. What we can do, however, is say that we know this one is going to be false because this one has already given us a whole number answer. So the only difference we've got to prove now is coming up with an example which will prove that whatever we put in will always be whole, or that it can come up with a non-whole answer or a decimal answer. As we know that 10 and 6 works, let's try what would happen if y equals 10 and x equals 5. Let's see if that makes a difference to our calculations. Now, it doesn't matter how many of these things you try. As long as you tried 1 or 2 different variations, any number of examples could work and help to prove our answer. So y squared is 100. Keep it easy by keeping one of the numbers the same. This time x squared would be 25. Find the difference between these two values. 100 subtract 25 is 75. So therefore the base must be the square root of 75. I don't know about you, I will not be able to find out the square root of 75 off the top of my head without a lot of written calculations. It is not a square number and therefore would end up giving us a decimal answer. So what we can say here is that yes, we can have a whole number, but if we choose a slightly different variation of this, we end up with a decimal solution. This is not going to be a whole number because this is not square, so therefore it will sometimes give us an answer which is a whole number. Any example which proves this, where you end up with a non-square number as your answer, will be enough to give you your 3 marks.